Now that we've covered Simpson's paradox, let's turn our attention to the topic of suppression. And there are two primary types that I'm going to talk about. There is classical suppression and net suppression. And I have to give credit where it is due. There is a professor at East Carolina University, and his website is noted at the bottom of this slide. And I've gotten a lot of great resources from his site over the years, just an FYI. He has example data sets to analyze with instructions how to do so, and he gives a great presentation of suppression. And so some of his resources may be helpful to you in the future. So the first type, classical suppression, is when we have a situation that is depicted in the Venn diagram, the first one at the top. And so there's this like chain shape where we have a dv at the far right, and then we have our x1 correlated with that, and then we have an x2 that's not correlated with the dv at all, but rather it shares all of its variance with the first predictor and none with the dv. And also note that the shared variance between x1 and x2 is not shared with the dv. And so this example it should be a little bit of a warning sign to us for regression. I'll show you why with all the details in the upcoming segments. But whenever there's this chain kind of pattern of relationships among the predictors with the dv, such that we have no shared variance in the dv with x2, but the variance that is shared between x1 and x2 is not shared with the dv, then this is an issue, and the b weights can have a weird interpretation. In fact, the bivariates, or the zero order correlations among those variables, will have different signs than the b weights. And again, I'll show you all of that coming up. The second kind of suppression is called net suppression, and it is depicted in the relationships in the second Venn diagram. We have a dv, and we have x1 correlated with it to a moderate degree, but then we have a big correlation shared between x1 and x2, but x2 only shares a tiny bit of variance with the dv. So it's like classical suppression, but not quite as severe. It's not a total chain effect as we see with classical, but rather x2 does share that little sliver of variance with the dv. But again, this creates a little bit of difficulty with interpreting the b weights and the bivariates and understanding what's going on with the relationships among those variables.